Hi, everyone. Welcome to the NLP Summit. I'm Ross Bierbryer, Head of Engineering at Dandelion Health. And in this session, we are going to discuss de-identification of free text patient notes. One of the problems that we're trying to solve at Dandelion is how do you de-identify free text patient notes so as to maintain patient privacy while preserving high fidelity data for researchers? It's non-trivial. There are HIPAA risks if you don't de-identify aggressively enough, and conversely, you can lose important research information if you de-identify too aggressively. So how can you have your cake and eat it too? During this talk, I'm going to tell you a bit about Dandelion and why we perform de-identification. Then we'll deep dive into our de-identification process for free text notes, touching on how we assess risks in corner cases, define metrics for success, and build around Johnson Labs Healthcare NLP with custom pre and post processing. Kicking things off, a bit of background. At Dandelion, we believe that clinical AI and medical research is only as good as the data it's built on. We catalyze the healthcare innovation process by partnering with leading health systems to provide safe, ethical access to curated, de identified clinical data of unparalleled depth, quality, and diversity. With our comprehensive longitudinal multimodal clinical data covering millions of patients, we're building the largest AI ready training and validation dataset in the world. All of the data we provide to our clients is de identified, and de identification is necessary because of the HIPAA privacy rule. The HIPAA privacy rule sets policies to protect all individually identifiable health information. This information is defined as the 18 HIPAA identifiers, seen here, and can be used to identify, contact, or locate a single person. When personally identifiable information is combined with healthcare information, it becomes protected health information, which I'll describe going forward as PHI. The privacy rule provides two de-identification methods. One, a formal determination by a qualified expert, or two, the removal of specified individual identifiers. We use the first option, expert determination, in order to explicitly measure the risk involved with the de-identification decisions we have made and to perform more nuanced data transformations. Once de-identification is complete, the privacy rule no longer considers the data as containing PHI. Now that we have a framework for de-identification, what is our process at Dandelion for de-identifying clinical data? Well, for each of our partner hospital systems, we have an account within their AWS organization. Everything we do has HIPAA compliance in mind. So our AWS account has no internet access in order to ensure a zero trust environment when handling raw data. No internet means that all of our processes either use AWS services within the AWS private network or air-gapped products that are containerized using AWS Elastic Container Service. As for the de-identification pipeline itself, in this internet-free environment for a given dataset, we send a series of de-identification requests to the SQS queuing service. This, in turn, fires up tens or hundreds of de-identification Lambda jobs. These jobs perform transformations on any PHI, and these transformations include redaction, hashing, or replacement. Once de-identification is complete, QA team members from both Dandelion and the hospital system confirm that de-identification was performed correctly. If it was, the transformed data is moved to a de-identified data store for egress. Otherwise, the transformed data is discarded and the raw data is reprocessed. For most tabular data, this is straightforward. A given column is either non-PHI and unchanged, or it goes through a particular transform. Redact the patient social security number column, for instance, or shift a doctor's visit date column by a random number of days. Free text patient notes are much more difficult to DID, as this requires PHI words and phrases to be redacted or masked, and then the whole of the patient note must be verified to be PHI free. With all that background context established, let's dive into patient note de-identification itself, which I'll use interchangeably with the term free text de-identification. For free text in a perfect world, we'd just iterate over each patient note, run healthcare NLP, scrub the PHI, and call it a day. Unfortunately, that's not the case because the patient notes we get are not perfectly processable by healthcare NLP. This is through no fault of the NLP itself or the hospital system. The NLP requires context for detecting PHI, and sometimes that context is garbage. This context might be extraneous information, weird formatting, or embedded metadata that only makes sense when a human views the data. For example, some notes may be stored line by line converted from a PDF document. If that PDF has a footer at the end of the page, there's a good chance that it's going to be pulled into that note. And if that footer has PHI, such as the patient last name and the date of the note, you're in trouble. I mean, I'm pretty confident that healthcare NLP detects the date in that footer, but if you're just stitching together each line one after the other, the word "doe" in all caps is going to be totally non-obvious that it's a patient name. It could be interpreted as an acronym such as date of event or date of expiration or Department of Education. Like, you don't really have the ability to discern what type of object that is if it's just thrown in the middle of a sentence. Um, and as another example, this is a weird one and something that we've encountered in the wild. There are some patient notes that we have processed that are stored as ASCII tables, where you would have symbols such as pluses and minuses delimiting the different rows and pipes delimiting the columns. So for redacting a date of birth, but let's say converting other dates to years per HIPAA regulations, this one is not intuitive for determining a birth date through NLP, since you're not going to see date of birth 5/10/1950. You'll see name, pipe, Dobb, pipe, weight, pipe, then a whole bunch of plus and minus symbols, then John Doe, then the date. So like, you really need to be able to extract this table structure and process that independently to be able to really confirm what types of objects you're processing. So those were some of the frustrating areas, but one thing that's nice is that there are some patient note structures that are super helpful for identifying PHI. Some patient notes always have headings and subheadings, which make it clear which sections to keep or throw away. Notes on systems with prepared templates for clinicians to fill out tend to have good, clean context for NLP, etc. So we know that this old process, run JSL, healthcare NLP, then scrub all instances of PHI, like it doesn't quite work. We need an alternative with a few extra steps for data cleaning or confirming data cleanliness. Our solution is adding 3 steps to the beginning of the process for a given note. 1, putting it in a modality category, radiology, pathology, etc. 2, determining the risk level for that category. And 3, reducing the risk for that category using category-specific approaches. In the next few slides, I'll be talking about those risk management steps. First, we categorize notes based on modalities. For example, radiology reports, echocardiogram narratives, or progress notes. A clinician performing radiology work, by the very nature of the work, is not engaging directly with the patient, so it's broadly a low-risk dataset for PHI. You see details like the size of a mass on an X-ray and not the personal background of the patient. Moreover, there can be templated form fields for certain notes, such as no abnormal sinus rhythm found, which can be seen on echocardiograms. On the other hand, procedure documents, which require description, such as operation on a 61-year-old male, inherently have PHI details. And a patient interview that has text that was manually entered by the clinician is high risk by its very nature. That all said, just because these assumptions exist doesn't necessarily mean that they are true. For example, just because a patient's name is not noted in a radiology report in most cases doesn't mean that there aren't radiology reports with patient detail headers or footers. Or using previous example, you could have a scanned in PDF that has some extra PHI data. So when we make these statements, we perform both manual and automated confirmation of these risks to be able to say with confidence, this is a low risk modality. Once we categorize the notes, we create strategies to reduce the risk for each category. This includes pre-processing, such as redacting headers and footers that are already available in the electronic health record. So things like patient names, addresses, dates of events, those are things that are all generally found in the electronic health record, and we want to get rid of those in the note. We also want to extract embedded tables into their own data objects, such as that ridiculous ASCII table that was seen previously. And we want to set aside notes that are particularly tricky in a given category. One interesting case that we found is obstetrics. Most age-related information is described using phrases such as 61 years old, but in the case of obstetrics, you can see phrases like 30 weeks or 10 days, and those can imply fetal or newborn age. So you have to be extra careful for phrases that are not normally considered to be age-related in these cases. Here's another fun one that we've hit repeatedly. CPT code or zip code. Procedure codes used for billing are 5 digits and can closely resemble zip codes. For our hospital system in California, our processes broadly assume that 5 digit numbers starting with 9 are zip codes, but outside of California, our processes broadly assume that these are CPT codes. But even still, you have to be careful about some of the context and say, like, okay, if we see the number 91311, are we talking about something that is COVID related? If so, we want to make sure that it is considered a CPT code. Otherwise, it is most likely a zip code. And then we'd also want to have some context, like, is there an address mentioned right before the 5 digit number? So that's all our pre-processing. For post-processing, after running healthcare NLP on free text notes, we will do a process called hiding in plain sight, or HIPS. The way this works is that for a given redacted token, we replace that token with a similar token from a dictionary. So in this case, for an example, we have the first name of Bob, and what we will do for a given note is we will replace that name Bob with Aaron 5% of the time, Antonio 6% of the time, Ben 10%, and so on and so forth. And you'll see that all of these instances do not necessarily add up to 100% because we're going to miss a few of these cases because we can't perfectly determine that Bob is a name because like you can have the phrase Bob up and down or names like May or April that can be interpreted as dates. So if we miss a name, it won't be obvious that that name was missed to an attacker because that name will have to be compared with other alternative names, and the attacker would have to know, oh, it's not Aaron or Antonio or Ben or whomever, it's 100% Bob, and that would be really hard to identify if you're using the sort of a cycling dictionary process. Based on research over the past 10 years, this approach is considered to reduce re-identification risk by about 90%. So if PHI detection recall is originally 95%, with HIPS, the effective recall is upwards of 99%. And just to give an example of HIPS in action, excuse me, without HIPS, as seen in the second column, it becomes obvious that the daughter's name is Lynn, the doctor's last name is White, and that the event happened on May 10th. In the HIPS scenario in the third column, these values of Lynn, White, and May 10th are mixed with other names and dates that are surrogates, such as Jones, Howe, and May 28th, making it non-obvious that the names were missed. So now that we have our processes established, how do we validate that we did the right thing? We measure our success with recall. specifically the number of true positive PHI that were redacted, divided by the true positive count plus the false negative count. This measurement is performed manually by human analysts who are clinically trained reviewers. These analysts review a sample result set of our automated de-identification process. If we miss more than a couple of dates, or if there's a social security number left hanging in our dataset, we go back to the drawing board and revamp our de-identification process. We also verify that for each category of notes, the formatting is consistent across years and subcategories, so we don't overfit to a particular subset of data. So just to give an example of how we would calculate the recall, if we see in our data set 100 instances of dates and we miss 5 of those, we would consider it a 95% recall since we've found 95 instances and missed 5. And we would think of that as potentially lower risk than a 95% recall because of HIPs, since we are jittering our dates and it's non-obvious which dates are missed and which are not. In addition, we perform precision cross-checking across our HIPS dictionaries and date jitters to ensure false positives do not reveal the masking mechanism. For example, we always jitter shift a specific number of days per patient to ensure that their event history does not get shuffled out of order. So patient A might get all their dates shifted forward 10 days. Patient B might get all their dates shifted backwards 2 days. This means that if the phrase normal value range of 1 to 2 is written as 1-2, but that 1-2 is processed as a date and jittered to 1-5, that means that you could reverse engineer every other date for that patient if you knew that the original normal value range was 1-2. Since then you can say like, okay, it was 1-2, now it's 1-5, the shift is 3, so every other date is shifted by 3. You can back calculate from there. So we do want to be careful that not just the recall is strong, but also that we don't have too many false positives that result in any information being revealed through our HIPS dictionaries. The aforementioned manual review process is performed by at least two analysts for a given document. So if we're reviewing a handful of documents, each of those documents are processed by 2 different reviewers. And what will happen then is that we compare any discrepancies between the analysts. And if there are discrepancies, it is triaged by a 3rd reviewer, and that may result in an analyst being retrained or replaced if their particular review quality is low, or for there to be additional clarification on a review process if something is unclear for whether it's a false positive or a real positive, that sort of thing. If reviewer quality is good, we compile the results, and if those results don't meet our quality thresholds, we revise our processing and repeat the de-identification process. Otherwise, we're done. We assemble our final report and we share results with our hospital system partners and perform automated de-identification on our full data set. That final report will contain information such as recall across each individual HIPAA identifier. So the number of names that were found, the number of names that were missed, the number of dates that were found, the number of dates that were missed, things like locations in the hospital that were found versus missed, or provider or clinician names. All of those are compiled and shared with our hospital systems so that they can be confident that we are redacting everything at the appropriate rate. And that's our entire process. First, we categorize each note based on its modality. Then we determine the risk level for each category, perform text pre-processing for the modality, run John Snow Labs Healthcare NLP to flag the particular HIPAA identifiers, and then we scrub all instances of PHI that is detected by healthcare NLP, perform text post-processing with HIPs so as to create additional masking and replacement of either dates or names or locations so as to make it harder for re-identification. And then we run validation for confirming successful de-identification with our thorough QA/QC. And through this process, we are able to uh, keep pretty much all of the data that we would find valuable for our clients while maintaining high security and high trust for our patients' privacy. Thank you. Enjoy the rest of the conference.